We are in Precalculus. We had a slight, maybe 2-week journey into review of Algebra 2 for trigonometry. Now that we've reviewed all that trig, we are coming back here to Precalc and learning about angle addition identities. So I thought it would be nice to just have a bunch of formulas all in one place. So if you're thinking, what was that trig formula? Just look at lesson 1-5. I told everyone, put a giant star right here. Put a giant star to let you know if there's something trig and there's a formula, it's probably on lesson 1-5. Today's date is the 5th of November. It is 11-5. So, by the way, these first two categories, Pythagorean Theorem and negative angles, those are not going to be tested tonight on our homework. Our homework, we only need Ptolemy's identities and double angle formulas. And of those double angle formulas, you only need 2 of these 4. And there are 4 examples today. Let's see if we can get, 5 examples. That's right. I added this 5th example because we needed a hard one. So you don't need to write down anything here. Just remember Pythagorean theorem, that's a squared plus b squared equals c squared. C again is our hypotenuse. Hypotenuse is 1 on the unit circle. That's where the sine and cosine come from here. Negative angles, these are things that we reviewed in Algebra 2 very briefly, but you don't need them. Here they are if you need them. This comes from being, can we just write this in our notes? From being, this is an odd function and this is an even, yeah, that's right. Even function. How's it odd? How's it even? If I had a piece of paper, it's hard to demonstrate via the computer, but if I have a piece of paper and if I look at sine, so sine comes like this, it comes down like this. If I fold it in half over here and if I fold it in half, you'll notice that this line over here, after I fold it, goes right there. So it doesn't quite match up. But if I fold it in half again over the x-axis, then the line is on top of each other. So even means you fold once and it's on the same line. Odd means you have to fold twice. So an odd function, I fold that piece of paper twice and it's on the same line, that's sine. Cosine is an even function, I just have to fold that function once. And to see that, this is our cosine function. It starts right there, comes down like that. If I fold just once right here, it's already on the same line. It's an even function. We can see that visually. I mean, it's way cooler if I had a piece of paper and did that, but yeah. So odd means you have to fold twice, fold 2 times. Even means you fold once. Yeah, it's kind of reverse, right? Even you'd think fold 2 times, but yeah, no. Fold 2 times means odd. All right, so Ptolemy. Let me give you a brief 2-minute tangent on who Ptolemy was. All right, do we know who Alexander the Great was? Alexander the Great conquered that giant area for Greece/Rome area. Yeah, he conquered a ton of area. He was Alexander the Great. He was tutored by Plato and all those people. I don't actually know if it was Plato, but he was super smart, and he eventually conquered a ton of area. So once he conquered that Egypt area down there, he decided to make a city in his name. So his name was Alex the Great. So Alexandria, there it is. The city of Alexandria, named after Alex the Great. And Alex the Great decided to put his city, maybe I should look at a Google map while I'm talking about this, maps.google.com. He decided to put his city not where most cities were at the time. Most cities in Egypt were on the Nile River. So if I come back over here to Egypt and scroll in, most cities were on the Nile. So there's the Nile River. Let's scroll out a little bit. Too much. There's the Nile River. Most cities were built on the Nile River. He decided to build his city on this Mediterranean Sea, on the coast of the Mediterranean Sea, which was kind of unheard of for Egypt, but it happened. Some people thought he would be unsuccessful. Most people thought he would be successful. He was successful because what ended up happening is it connected his city to a bunch of other cities via the Mediterranean Sea. He was able to look north and see his home of Athens in Greece. Anyway, so Alexandria exists. Cool city, right? It was the place that you would go to if you wanted to study. It had the Library of Alexandria. Super famous. Like, if I could name one famous library in all of history, that would be the Library of Alexandria. So why was the Library of Alexandria so amazing? This is what they did. They stole anyone's work that came in that was a book. You have a book, you have a roll of paper, you have any writing whatsoever, they immediately confiscate it. They say, that's ours, give us some time. They would manually copy it down by hand. There were no printers back then, and they would give you the copy. They took your original and kept it in the Library of Alexandria. Super amazing place. Okay, what happened was eventually Alexander the Great dies. The power, or the city of Alexandria is turned over to Ptolemy. Ptolemy was in charge of the city of Alexandria. And if you want to know what happened, the tragedy of the Library of Alexandria. So do you guys know who Queen Cleopatra was? She was like the last pharaoh of Egypt, and a woman at that, which was super cool at the time. She went to war with Ptolemy, and that famous general, I can't remember his name at the moment, but general and her teamed up. They fought against Ptolemy. They decided that it would be a good idea to burn all the ships in the harbor of Alexandria, which was a good idea. They destroyed all the ships, but the ships were so close to each other that the fire spread from ship to ship, which is good, except that it eventually went to the shore. It caught all the houses on fire. Houses eventually caught all the stuff next to it on fire. It caught the library on fire and burnt everything. It was all gone. So this giant plethora of knowledge, it was so much knowledge lost in that fire. Luckily, Alexandria, that library, had a bunch of different libraries scattered throughout. Eventually, that would be the place where people like, what was her name? Oh, I'm blanking on her name. Hypatia. She would eventually study at one of those auxiliary libraries. Anyway, long story, but Ptolemy was one of the people that was in charge of the kingdom of Alexandria. And I don't actually know if he discovered this or if someone discovered it and named it after him because he was a cool dude. But these are his identities. Notice what those identities are. Every single one of these goes A, B, 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 A, B. It always starts with the first, ends with the second. A, B, A, B. We see that pattern, yes? Notice what the other pattern is. If I have a sine out here, it starts with a sine. Sine starts with sine. Cosine starts with cosine. Cosine starts with cosine. Cool pattern. Other pattern that you should look for. All of the signs change. It goes sine, then cosine. Sine, then cosine. And this relates to calculus, Rochelle, because when I take the derivative of sine, actually it's the antiderivative. Maybe it does relate in not the way that I thought it does. But anyway, sine changes to cosine. Cosine stays the same. Cosine, cosine. Cosine goes cosine, cosine. Okay, lots of patterns here. Other pattern here. This is the relationship to calculus that I wanted to talk about.
How is it that way? You know the derivative of cosine is negative sign?
Yes.
Why is there positive and negative?
Right on this side, right over here.
No.
Over here.
Yeah.
So check this out. Sine, derivative of sine is positive cosine, right?
You know it's two cosines.
Yes.
Two cosines. Okay, next two. No, not those two.
Just get up to the board point.
So these two cosines.
Yes.
The derivative of cosine is negative sign. How come right here there's a negative sign and a positive sign?
Great question. So look here. When I have a positive here, derivative of cosine, as you said, was negative sign. So this positive will turn into a negative. But if I start with a negative, right here, then it turns into a positive. So it changes the sign. Remember, derivative of cosine means you change. And that's something that you'll just remember, Daisy. If I start with a positive, it turns to a negative. If I start with a negative, it turns to a positive because it's cosine. However, with sine stays the same. Stays the same, stays the same, stays the same, stays the same. There's lots of patterns in here to help you memorize it, but as I said before, you will have a cheat sheet for this on the test. You will be either using part of notes 1-5 or you will be writing these down on a note card. These do not need to be memorized. So that's Ptolemy's identities, not enemies. Ptolemy's identities. We're okay with this? Moving on to double angle formulas. Again, these two right here, you need to have ready to use. You need to be ready to use this on the problem set, the quiz, and the test. All right, double angle formulas. So Ptolemy's identities work for something plus something else or something minus something else. What if you decide to multiply? What if you decide to multiply specifically by, I don't know why it does that, by 2? If I multiply that original angle that I'm trying to find by 2, use this formula, 2 times sine times cosine. If I have cosine, that changes to cosine squared minus sine squared, and you can use a lot of trig rules that have been talked about up here in order to transform that into these other ones. But you only need to remember one of these. Choose your favorite one. My favorite one is this one right here.
Why? Choose your Pokemon.
Why is this not working? My favorite one is this one right here. You can choose any of these 3 for cosine.
Why?
All of these 3 are the same rule. They're
No,
just
I meant, like, why is that your favorite?
Why is that my favorite? Because it is a direct translation of sine squared and cosine squared right here. You might like one of these more than the other because you don't have to do the sine and cosine of an angle. Anyway, those are the angles. I don't care if you memorize them because you will never have to memorize it for the rest of your life. Maybe the same rule as some other things that we learn. I was going to go on a tangent on that. I decided not to. Let's just look at an example. Find sine of an angle minus 30. Which of these rules do you think you're going to be using? Of these 6 rules, Ptolemy's and double angle formulas, which of these 6 rules are you going to be using for example 1? Do you see it? Is it the first, second, third, fourth, fifth, or sixth? It's sine, first of all, so it's not cosine, it's not cosine, not cosine.
So it's gotta be the third sine.
Third one?
Second sine.
This one? Is it 1, 2, or 3?
I feel like it's 2, but then also 3.
I see.
It's 2. There's a minus sign. There's a minus sign, there's a minus sign. It's rule 2. Okay, so you don't have to memorize rule 2, but you need to be able to rewrite it down. So sine of A, let's write down. Sine of A times cosine of B minus cosine of A times sine of B.
Write this down. There's not gonna be enough space for us.
We're basically done after one line. We have one line, then we simplify. There's technically a total of 3 lines. All right, here we go. It isn't that hard, I promise you. The hard part is memorizing the formulas, which I'm not making you do. A and B in our formula just refer to the first and second number. The first number is A, the second number is B. First number, there it is. Second number, there it is. Don't treat this as negative 30, just treat it as 30 because the sign is already taken up by the formula. All right, so ABC. ABC is talking about this angle right here. Let's go back all the way to, I don't even remember, maybe Algebra 1 when you first learned about Sohcahtoa.
Oh no.
What is, I think we reviewed this in Algebra 2 as well. Sohcahtoa, this was probably lesson 1 or lesson 2 of our review in Unit 9. If I take sine, Sohcahtoa, so S-O-H, O and H are what?
Opposite and
Opposite over hypotenuse.
Opposite over hypotenuse. If this is my angle of reference, what is opposite? Is opposite 3, 4, 5?
3.
Daisy, you concur? It is 3. So let's go ahead and write that down. 3. What's the hypotenuse?
5.
There's my fraction. Sine of A, or sine of angle ABC, is 3/5. Done. There it is. There's 1/4 of it. You're 1/4 the way there. I need to multiply that by cosine of B. But before I do that, let's step back. Do you understand that sine of A is 3/5? Do we understand how to get there, Daisy?
Yes.
Okay, so far so good. I was just calling on her because I want to make sure that her writing is not interfering with her learning because there's 2 different skills. All right, cosine of B. B now is 30 degrees. Now you're remembering all the way back from actual Unit 1, you have to have memorized what cosine of 30 degrees is.
That's going to be.
Wait.
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 Cosine of 30 degrees. Remember how to do this? Cosine of 30 degrees. That's what this thing is saying. Cosine of B is cosine of 30 degrees. And you think, okay, we made this 30, 60, 90 triangle. That one was 30. That one was 60. That one was our 90. And then that one was 1 because that was the hypotenuse. You had to fill in these dimensions here. Do you remember how to do that? Rochelle, yeah, you want to help us out?
Oh, I already know it.
What is this dimension right here? What is this y?
Like it's 1 over 2.
It's 1/2. Yep, 1/2. Daisy, do you remember this one? For a 30, 60, 90, you have to have this memorized.
Is it?
Ooh, you're so close. You're
Wait,
so close. I'm going to write 3/2 because you just have to modify it.
Oh, is it the I don't know.
What is it called? Yeah, say it. Say it.
I don't remember.
Square root.
Second power? I don't know.
Square root of 3/2. There it is. Those are the dimensions that you have to have memorized for 30, 60, 90. And then the next question that you ask yourself is cosine asking for the x or the y coordinate? I know Rochelle knows it. Let's see if Daisy can. It's a 50-50. Is it the x or the y, Daisy? It's the x.
Oh,
Okay, so Daisy, help us out. The x coordinate, which of these 3 things is the x coordinate?
I look at it as if it was a
Yeah, think of a circle.
Look.
What? Oh, right. Okay.
X direction, is that left and right or up and down?
It's left and right.
Which one of these is left and right?
The square root of 3 over 2.
There it is. Square root of 3 over 2. That was cosine of 30 degrees. You have to have that memorized. And you'll need it for the test as well. You have to have that triangle memorized. You need to know how to, if cosine is asking about the x or the y. Let's move on. Cosine of A. What is that really asking for? Cosine of A, am I talking about the triangle or the stuff that I have to have memorized?
Triangle.
The triangle, yeah. So cosine. What is cosine? C is... Give this one to Daisy. Sohcahtoa. C is what over what?
Sohcahtoa, it's A over H.
A over H. And then Rochelle, what is A?
A is 4. And then H is 4.
4 over 5. There it is. Cosine of A, cosine of this angle ABC is 4/5. Sine of B. Well, now I need to do sine of 30 degrees. Hey, Mr. Sindel just gave you the 30, 60, 90 triangle. There's 30 degrees. Sine, Daisy, is asking for the x or the y. Remember, cosine was asking about x. Sine is asking for the y. So therefore, sine of B is...
1/2.
There it is, 1/2. And then we simplify this. Here we go. Simplified. 3 times square root of 3 is 3 square root of 3. You can't simplify it anymore, aside from just squishing them together. 5 times 2, Rochelle, is?
10.
Oh, yeah, it's 10.
Ew.
Oh, yeah. Daisy, 4 times 1 is?
4.
Daisy, 5 times 2 is?
10.
10. And let's go ahead and rewrite this 4 tenths. Let's just get rid of the 4 and 10 and simplify this to, Daisy?
2 over 5.
2 over 5. The final answer is 3 square root of 3 over 10 minus 2/5. There's our answer. Done. Whew, so much math. Not only do you have to memorize the 30, 60, 90, 45, 45, 90, and cosine and sine are x and y, and Sohcahtoa, but now you need to apply these rules on top of it. Math is just a collection of rules with the conceptual understanding of why they work, and you apply all of that. So let's try it again. It's so much work, I know, but we can do it together. All right, first of all, what rule am I using? Cosine of ABC plus 60. Which of these 6 rules am I using?
The first cosine.
The first cosine, Daisy, do you agree that it's this rule that I'm
Yes.
circling right here?
Yes.
It is? Okay, let's go ahead and rewrite it down. Cosine of A times cosine of B.
Okay.
Cosine of A times cosine of B. I don't want to discourage us from not memorizing, or discourage you from memorizing the formula. So if you decide to memorize it, and you memorized all 6 of these rules, you don't have to memorize those 2 if you don't want. Just remember your favorite one. If you do memorize all of them, I will give you 10 extra credit points in your extra credit tracker. It's up to you. All right, this one is going to be minus sine A times cosine B. I totally memorized that. Maybe it's correct, maybe it's not. Oh, I got it right. All right, so first of all, cosine of A. It's talking about measure ABC. ABC.
Wait, what?
You
What
got
are
it
you
wrong.
talking
I got it wrong?
Yeah, it's
Oh.
sine B. Not cosine B.
Oh, it is.
Wait, where are you guys looking?
You know what you're-
Oh, it's this one.
Wait, what? A plus B. So cosine of A times cosine of B. Cosine A times cosine of B. And then I should say minus sine A sine B. Minus sine A. Ah, that's the where. Yeah. So go ahead and give yourself the extra credit point in your extra credit tracker. Should say sine of B. I have not memorized it. I will memorize it by tomorrow, I promise. I'll work on this as well tonight. All right, so what is cosine of A?
Cosine of A is
Talking about cosine of this angle.
It is 5 over 13.
It is 5 over 13. Daisy, why is it 5 over 13?
5 over 13.
Mhm.
Is it because it is the opposite over
Opposite would be 12 over 13.
Oops, sorry, the adjacent.
Adjacent over hypotenuse. There it is. Yep. We're going to multiply that times cosine of B. Well, cosine of B is cosine of 60 degrees. Maybe it would be helpful to have a 60-degree triangle over here on the left-hand side. Here's your 60, 30, 90. I know that the hypotenuse is 1. Either Daisy or Rochelle, give me one of these numbers. The other girl will give the other number. You can say the short side or the long side. Which one is 1/2, Daisy?
It is the. Can you let me answer this for once?
Is it the short side or the long side?
It's long.
Long side right here?
Yeah. Oh wait, no, it's the
Yeah. Because 1 is smaller than square root of 3. Square root of 3 is a little bit bigger. And then Rochelle, therefore, this side is.
You just said it. Square root of 3 over 2.
And therefore, Rochelle, cosine of b is.
Yeah. Sorry, what was that?
Therefore, cosine of 60 degrees is
1/2.
1/2. Because you're asking for the x coordinate. The x coordinate is going left and right. It is 1/2. Minus. All right, Rochelle, you're going to do sine of a.
Can I do both?
And then
Yeah,
Daisy's
go
going to do sine of b. No, Daisy, get ready to do sine of b. I need both of us to participate. That's why.
Can I do side B?
I think Daisy needs more practice than you do because you have this reviewed already.
Yeah, you can.
So, Rochelle, you're giving me sine of a. Daisy, get ready for sine of b. So, Rochelle, sine of a is
12 over 13.
12 over 13. It is 12 over 13 because sine is what ratio over what ratio, Rochelle? Using Sohcahtoa? Sine is
Opposite over hypotenuse.
opposite over hypotenuse. There they are. And then Daisy, you're up. Sine of 60 degrees is?
Sine of 60 degrees.
Yep. Use your triangle.
Is what?
Use your triangle over here on the left-hand side.
It's 1/2, right?
So sine is asking for the y coordinate.
Oh, for the y coordinate. So then it would be square root. Wait. Yeah, 3 over 2.
Yep, that is correct. And simplify this on the next line. Rochelle, you want to simplify it for us?
Sure. It would be 5 over 26.
Minus.
Oh, I keep going?
Yep, keep going.
Yeah, 12 times the square root of 3 over 26.
Which reduces to?
That'd be 2. No. It would be 6 over 13.
There it is. There's your answer. Whew, we're doing good so far. All right. Let's try our double angle formulas. These have 2 times something. We're probably going to be using 2 times something. So it's going to be one of those two. Let's try the cosine first. Find 2 times the cosine of BAC. Am I talking about the top angle, the right angle, or the left angle? Which angle am I talking about? BAC.
The top.
Top angle, yep. BAC, BAC, it's the middle one that I'm always talking about, which is A. All right, so I'm talking about this angle. Let's go ahead and write down the formula. Cosine of 2 theta. I'm going to do cosine squared minus sine squared. You can do any of these 3 and they will work. But I'm going to do this one because it has both examples in one because we have to do cosine squared anyway. So cosine squared minus sine squared. Cosine squared of theta minus sine squared of theta. All right, so what is my theta? There is my theta. Well, what is cosine? If this is my angle of reference, what is cosine of that angle? I'm going to give this one to Rochelle. Daisy, you're going to do the sine. Sound fair? All right, so cosine. Tell me, Rochelle. You don't have to do the squared yet. Leave the squared. I'll go like this. There's my fraction squared minus my fraction squared. Don't square it yet. Just tell me what the fraction is for cosine of my angle of reference. No.
3 over 5.
3 over 5. Like that? Okay, yep. And then Daisy?
Now you're about to doubt me.
I was about to doubt you, but then I realized that my angle of reference in my head was wrong.
So then sine would be. Wait. So cosine is
Adjacent.
adjacent over that. So
Yep.
then it would be 4 over 5.
Yep, because that is what over what?
That would be opposite over hypotenuse.
Exactly. Sine is opposite over hypotenuse because it's Sohcahtoa. Perfect. And then let's go ahead and square these really quick. Daisy, you're going to square the right. Rochelle, you're going to square the left. Go.
Wait.
So, Rochelle, 3/5
Oh.
squared is?
So what was that?
3/5 squared is?
9 over 25.
And Daisy, 4/5 squared is?
16 over. 16.
Close.
5 times 5. 25, sorry.
Cool. And we can reduce this because they have common denominators.
I'm having a brain fart right now.
We can reduce this into what? Someone shout it out. It's going to be a negative something because I have a bigger.
Oh, you're going to subtract this
There it is. There's our answer.
Why on this one are you actually simplifying that?
I'm simplifying this one because on this one, Khan Academy simplifies, and on this one, Khan Academy doesn't simplify. I'm just getting you set up for what the homework is going to look like. You can simplify both of these, right? Because this one was originally over 10, so I could have done 3 square root of 3 minus 4 all over 10.
That would be negative 1 times square root of 3 over 10.
What?
If you didn't simplify it.
Oh.
Negative 1 times the square root of... No, because that's not how you combine fractions. You have to be careful there. This has a rational, this doesn't, so you have to leave them separate. Yeah, but that's okay. Let's go ahead and do number 4.
What if you made it rational?
So you multiply the top and bottom here by square root of 3. Bless you.
Ooh, that hurt me.
Are you okay?
Yeah, I'm good.
And it wouldn't work because the bottom would have a rational, and fractions can't have rational.
Yeah, you have to rationalize the denominator. So yeah, just leave it like that. You just leave it as 3. Okay, so yeah, this is Rochelle's note. This is Rochelle's answer. This one can be simplified to 3 square root of 3 minus 2, all of that over 10. That's another way to simplify it. This is how Khan Academy leaves it though, because it's Khan Academy. So Khan Academy will do multiple choice, and that's what one of the answers looks like.
Oh, it's multiple choice.
It is multiple choice, but for these ones, it's free response. Example 3 and 4 are always free response. That's why I'm showing you the full simplified answer. Let's do number 4. Write out a formula for sine. There's only one formula, and it is what?
That would be
Double angle formula for sine.
sine squared
Sine squared of theta.
Mine? Oh no, it's 2 sine times cosine.
2 sine, you're good. 2 sine
Theta.
theta times cosine of theta. Perfect.
Theta.
Theta?
It's theta.
Theta, yeah.
Theta.
I got beta fish for my birthday.
That is super exciting.
No, I really did though.
Let's go ahead and multiply this. There's my 2, and I'm going to multiply by a fraction here times a fraction here. I'm just setting it up. I know that I'm going to have a fraction. By the way, I consider these ones to be easier than the other ones because you don't have to memorize what sine of 30 or sine of 60 degrees is. So, Daisy, you're going to do sine of theta. Rochelle, you're going to do cosine of theta. I'm talking about BAC. Again, BAC, you're talking about that same top angle here. So, Daisy, what is sine of that angle of reference?
So sine would be 5/13.
You are correct. And Rochelle?
12 over 13.
12 over 13. And multiplying those together with a 2, I guess I can come back here. Instead of doing a 2 like that, I can do a 2 like this.
2 over 1.
Exactly, 2 over 1. If I multiply all these things together all at once, 5 times 12 is 60, times 2 is
120.
120. 13 squared, look up there, 13 squared is,
169.
there it is, done. I'm glad we can be so mature in here. So, we're on example 5. This one is the hardest type of question I can ask you about double angle formula because we have a square root in it. I want to make sure that we know how to simplify things that have square roots in it. So, again, cosine, we know the formula. It's cosine squared minus sine squared or any of the other ones. Do you want to use a different one just to try it out? Try it on for size, or do you want to use the same one?
What do you mean different?
Because there are 3 equations that I can do for cosine of 2 theta. I can use this one, or this one.
Let's try this. Number 2 and 1 are, number 2 and 3 are the same thing. It's just you move negative 1.
Well, one of them is cosine squared, one of them is sine squared. They both have a 2 in them.
Then what's the point of using the third one if it's sine? Couldn't you use that one for the sine 2 bit theta? So both of them would have 2 formulas.
Sine of 2 theta, but this one doesn't have a 2 theta in it. So all 3 of these are only for cosine of 2 theta. There's only one formula for sine of 2 theta, it's this one.
How is there sine and cosine, but not sine for sine?
Or you want me to prove why these are the same things for cosine 2 theta?
Well, maybe prove the third one.
I can prove that. Can I do that during lunch or another time? It's going to take a little bit of time. Okay, so I'll add a note, prove this for Rochelle. Prove for Rachi. Okay. So let's go ahead. Let's just go ahead and use the first one because we're not being decisive enough. Let's do cosine squared minus sine squared. Cosine squared of theta minus sine squared of theta. All right, so there's my cosine squared minus there's my sine squared. Rochelle, can you do cosine squared and Daisy, can you do sine squared? You can go ahead and simplify it too if you want. So,
Doing sine?
Rochelle, cosine, yep. Daisy, you're doing sine.
So it would be 2 over 2 times the square root of 5.
2 over 2 radical 5. Okay. That is indeed, so ABC is talking about this angle right here, so cosine is indeed that, and then sine is what, Daisy?
Wait. I'm doing sine then?
Yep.
That would be opposite over hypotenuse.
Yep, opposite over hypotenuse.
2 over...
Oh, opposite is on the opposite side of the angle.
Right, so it's 4
Yep, opposite is 4.
over 2 to the square root of 5.
Cool. Now, how do you square each of these? This is some maybe review that we haven't seen before, for a while at least. 2 squared is?
What's 25? Oh, so it'd be 4 over 100.
Careful, it's not 4 over 100. So-
No. It's 4 over 20.
Yes, it is 4 over 20. Because I squared the 2, so let me write over here on the side. 2 square root of 5 squared is equal to 2 squared times square root of 5 squared. And what happens there is the square cancels out with the square root and you're just left with a 5. So it's 4 times 5, which Rochelle correctly gave us as 20. Daisy, you want to give the second one a try?
No.
You got this. I believe in you. You got this.
Not really.
Go for it. You got it. You got it. 4 squared, Daisy.
4 squared is 16.
16. And we know what the bottom is because this is the same bottom that Rochelle gave us, over 20. And that simplifies even further to what? Anyone?
Negative 3 over 5.
Ooh, you went so fast. I'm going to do 2 steps. Is that okay?
Actually, I didn't go too fast. I already answered it.
Negative 12 over 20. And divide the top and bottom by 4, which is negative 3 over
Oh my God,
5.
I'm sorry.
There it is. Okay, that's it for the notes. Go ahead and write your summaries. Your summaries, don't write the formulas because those formulas you don't need to rewrite unless you want to try to memorize them. Your formula or your summary should include something like make sure to match up the correct problem with the correct formula or something like that. Make sure you're talking about the correct angle. Things that you might make an error on, just look back. Or in the summary say don't memorize them, just use the cheat sheet. That concludes today's notes.